Welcome back. In this video, we will look into the application of recursion in solving simple computing problems. To start, we will study how factorial works, and we will write a method that computes the factorial of the given number. And afterwards, we will rewrite that method into a recursive method. In order for us to understand the process of factorial, let's take some example on how we compute the factorial of a given number. So normally, if you are given an input of 4, to compute for the factorial of this number, what we will do is to multiply the given number to the numbers that are less than the given number. In our case, the given is 4. We have to multiply 4 by 3, 2, down to 1. So this is the process. We will multiply 4 with 1, 2, and 3. Or you can also multiply it by following this order: 4 times 3 times 2 times 1. Or you can also multiply this by starting at 1 up to the given number. No matter what is the order of how you will multiply the numbers, what is important is that you multiply the given number from the numbers that is less than the given number. So all of these examples, from this example and the second example up to the last example, all of these are equal. All of these will return the same result, 24. Let's take another example. If the given is 7, then we have to multiply 7 from the numbers less than 7. So those are 6, 5, 4, down to 1. So the process will take these steps. So 7 times 1 times 2 up to 6. Or you can take this step, 7 times 6 times 5 times 4 down to 1. So no matter what is the order of how you will multiply the numbers, what is important is that you will multiply the given number starting from itself down to the numbers that is less than to the given number. So the result of this is 5040. So now let's try writing recursive methods to implement computation of factorial. I have already created a project that will serve as example for writing recursive method for solving factorial. So to start with our factorial, let's start using a for statement, and then later we will convert the for statement into a recursive method. So let's write here okay, so what we are doing here is that we are preparing the statements that we need to use for computing that factorial of a given number. So we'll start by creating an integer that will catch the input of the user. So in this case, that is our x. And then we will try to validate the input of the user if it is a valid integer. If it is not, then the invalid variable will contain a value of false. Now, if it is false, then it will state that the input of the user is not a valid input. But if it is valid, then this is where the place where we will write the instruction for computing the factorial. Okay, so let's explain what we have written here. We created a variable. The name of the variable is x, and the data type is integer with an initial value of 0. We created also another variable, a Boolean variable. The name is invalid, which initialized to false. And then we call the try-parse method. So it will read the input from the user, checking if the input is a valid integer. If it is not, then the invalid variable here will contain false. Otherwise, X will contain the valid input. If the invalid variable is false, then it will tell the user that his input is not a valid input. And another thing, if the X is still 0, then it means that the factorial of 0 is 1. If the first condition is false, as well as the second condition is false, then it will go to the else part. We will create a variable res containing the result. We initialize it by 1, and then we iterate. We created a loop statement that will iterate from the input of the user down to 0. And as it loops, it multiplies the value of the res variable to the value of I. So after completing this loop, we will now display the value of our res. But for our case, we have an error here. It states here that the name res does not exist in the current context. So meaning we created the res variable and we call the res variable outside of this block. So res is not known on this part. So that is why we have to put this somewhere at the top right here so that we can get rid of that error. All right, so let's give this a try. So let's take an input of 4 and then it gives us 0. We have an error. So why we have this 0 as our result? Okay, so let's check. It's because we have this 0 as our final counter, as our termination for the for statement. So any number that is multiplied by 0 will give us 0. So that is why we have to turn this to 1. Okay, so let's give this another try. Let's write again 4, and then it gives us 24. Let's have another example. So let's say, let's give this an input of 7, then it gives us 5040. So there you go. This is how we write factorial using the for statement. So this time we will convert the for statement factorial into a recursive method. At the bottom of our main method, we will write here the definition of our recursive method. Static int, and then let's name this factorial. And then let's have a parameter variable inside of our factorial. Let's say num. And then this is where we write our statements for factorial. So the first thing that we have to do here is to identify when does this factorial should stop computing the factorial of a number. So normally we will stop if our factorial, if our n is already 0. That's the time that we're going to return a value of 1. And then we will write here return another return statement. Then we will do a recursion here, calling the name of our method factorial, supplying our value num minus 1. So what happens here is that as it loops back, the num is decremented by 1. And when num reaches 0, then it returns 1. Then it will stop the recursion right there. To complete this, we have to multiply our factorial with num. So let's give this a try. But before that, we should call the name of our method inside of our main method. And then on this part, we will comment this out. We will call our factorial method inside of our write line. And then supplying the input from the user. So there you go. And then let's give this a try. So let's give it an input of 4. It gives us 24. And then let's try a different input. Let's say 7. And then it gives us 540. Let's try another different input. Let's say 0. Then it gives us 1. And then for the last input, let's try, let's say 5. So there you go. So with this, we were able to transform the computation of our factorial from for statement going to a recursive method. So as you can see the beauty of the recursion, we only wrote a few lines of codes here, but we were able to compute the same result that we have for our first statement. So that is the beauty of recursion. So that's all for this video, and then see you in the next lectures.